Hi, can you all hear me again and see me before I start off chatting? All okay? Yep, perfect. Thank you, Mark. Lovely. Yep, great. So the last one, Sights and Sounds, Dan, thanks a million. Yep. So basically the last lecture that I just gave you there was on the agile software development approach, and we looked at one of the toolkits associated with it, which would be the test-driven development approach within that agile approach. So I mentioned that we use this framework called JUnit, and how it automated your tests and how you could clearly see whether the test was successful or not. So what I'm going to do now is just go through and kind of just what exactly is JUnit. So we're going to look at it and look at it within the Eclipse environment. We'll do a couple of tests on a piece of a little bit broken code, and we'll have a look at what's outputted and how we can see whether it's not working and how we fix it, and then we can see it's working. So we'll just play around with the code through the slides for the moment. So we're looking at this JUnit framework. So it is a testing framework for Java. JUnit, as I said earlier, it's part of what we call the XUnit framework. So different languages will have their own framework. And what it does is it's going to enable us to write and run repeatable tests. So we're going to start automating our testing. And it's used, as it's a unit testing framework, it's used to test small pieces of code. So methods or a class. Each class will have its own, typically will have its own JUnit class. And within that, there'll be several methods, test methods in there. And they will test a lot of the methods that are in your original system under test. So as we were saying about the test-driven development, developers should ideally write and execute the JUnit tests before writing any code. So that's the approach that we try and encourage you to do. It is a learned skill, and you may find it easier at the moment to write the tests concurrently with the code you're writing. So you'll find you'll get into a groove of it as you're going through it. So there is the versions that we're going to be looking at in this course, and the reason why we're going to look at the three versions that are there is because they're very different in how you write the code for them, and they use different annotations, and we look at all this in a second as well. They use a different approach, and you need to know the three of these so that you can maintain anything that's in the wild on it. So JUnit 3, we're going to look at JUnit 3 first, and that's what these slides are kind of based on. JUnit 4, the lab that you're going to do is based on JUnit 4, and the version that we're going to use is 4.12. And there's a reason why we're using 4.12, and it's to do with Hamcrest core downstream dependencies. Sounds very fancy. We'll show you it. I think Eamon's going to go through that with you next week. So we'll look at JUnit 4 and how we're going to use that. And then JUnit 5, I'll move on to when we start doing the Maven stuff in week 6. I'll start pulling in JUnit 5 stuff into our labs so that you can start using it. JUnit 5 is the first general availability release was September the 10th, 2017. Now it has been out there, but it's only kind of beta versions and stuff. So the bug fix version was released on October the 3rd. So you can see it's incredibly new, but yet you still need to be able to do it. Now it's so new that when I wrote these slides about 2 weeks ago, it wasn't really supported in Eclipse, the IDE. And we're going to use you start pulling it down, but now there is an alpha version out there for supporting it. So there is now support for the Eclipse IDE, but it's a very embryonic level of support. So what we're going to do is we're going to use Maven, which is our build system. We'll show you all about that in 2 weeks' time. We'll use that to pull down the capability into Eclipse. So it's a nice way of showing you how to use it on a project-by-project basis. So let's get cracking on it. So JUnit version 3. Conventions differ between them all. So different annotations, different ways of writing the test. So you have to know version 3 and 4, and 5 would be desirable. You saw how new it is, how much code is out there in the wild. But once you know version 3 and 4, it's very easy to do 5. It's just a matter of looking up to see what annotations have been used. So in version 3, the test class must extend this superclass called test case. The setup teardown methods are overridden from test case. They are optional methods. I'll tell you what exactly those guys are now in a second. And the test methods, when you write a test method, it must begin with the word test. That's how the JUnit framework in version 3 recognizes that what you have written is an actual test case that you want to run. And when it extends test case and you have a test method beginning with the word test, it knows it's part of it's supposed to be a JUnit automated test. There's your test. Now, see, you can go up to have a look at all of this. You can see I just kind of left in a little bit of it's kind of cut out a bit, sorry, a little bit of the URL there. You can have a look at it. And this is the API for it. So it tells you a little bit more here. You must implement a subclass of test case. Number 2, you must define instant variables and so on. We'll go through all of that now in this class here, and this lecture here. So that's what your code is initially going to look like. You're going to import the JUnit.framework.test case, and then what you'll do is you will extend test case. So then when you try and run this as a JUnit class, it'll be recognized by what we call test runners. So within this JUnit, within this test case class, you can see there's a lot of different methods here. We're interested in this setup method and this teardown method. And we can override those to do the setup. Will set up what we call the fixture. So a fixture is basically the data that the test dummy data that we're going to create. That's what a fixture is. So you can use the setup method to override or to basically set up all of the test data. The setup method is called before every single test method that's listed in this particular class, this test case. You don't have to include them, but you can if you want to set up your test data. There's a teardown method. The teardown method that's in this test case class that we will override in our JUnit when we write the class ourselves. It will tear down the text fixture. So it will restore your test data to a starting state. Okay, and so we can use those guys. We'll use those 2 methods mainly. So in this case, as I said, they're optional. You don't have to use them. I don't have a colossal amount of test data. So I'm a very small test class. So I didn't really do any kind of setup and tear down. I don't have to do them. But each test, see here, there, public void test order. Each test method must begin with the word test, lowercase test. And this is in JUnit 3. JUnit 4 doesn't follow that rule. We use instead what we call annotations, and Eamon is going to look at that with you, and you'll also be doing it in your labs. You'll see these annotations creeping in. So assertions. So within this test here, we've got what's called an assertion, assert equals. So if you just look at the code here for a second, we're doing a public class test largest. So that's just the name of the class. We're testing the largest of something. And if we look here, we've got a primitive array here that has capacity to store 3 elements in it, 3 integers. The 3 integers are 8, 9, and 7. So what we are saying is that we will have some sort of class called largest, and it's a static call to a method here, largest, another method within it called largest. We'll pass out this test data, this array that we've just set up, and when that method is called, we are expecting that 9 is going to be returned based on us passing in our test data of 8, 9, and 7. We're expecting 9 to be returned. And that's what assert equals means, is I am asserting that the result from that largest method call by passing out that array data is going to be 9. Okay, so to check if, so what assertions are is they're what we use in the JUnit framework to tell us if the code is behaving as expected. We make a little call, we make a method call to our system. So our system, if I just page up there, our system under test is this guy here, this class here, this largest class. And there's a method called largest within it that accepts an integer array. So that's my system under test. I am expecting that when that is executed, because that's a call to the system, it's going to execute it, it will return the value 9 to me. So my assertion is a simple method call that verifies that something is true. And that's what it is. It's verifying that the value 9 is returned to me. So you see here as well that there is just above this test case class that we imported, you can see that there is a class called assert. And that is where all these assertions are coming from. Okay, and if I scroll down a bit more, you'll see that there is a set of assert methods. Messages are only displayed when an assert fails. Okay, so if the assert passes, it doesn't tell us anything. It's just great. Everything, all's good if it passes. It'll only throw a message out if it fails to us. There's a lot of different assertion methods up in this class. So what we have is things like assert equals. Okay, you can check this one is that a string, an expected string against the actual string. The one that we were looking at was an expected int against an expected int. So there's lots of these assert equals methods. And there's also assert false, assert not null, assert not same, assert null, assert same. And we'll cover a good few of these guys with you. There's a huge number of those methods up there. That's only a tiny few of them. So using asserts. So you could use this assert to check all sorts of things, including whether numbers are equal to each other or not. So we're setting up a variable called a, setting it to 2, and we're asserting that this is true. Is a equal to, this is a Boolean expression here, is a equal to 2? It's true, yes, so it is true. So another one there, to check that 2 integers are equal, a method that takes 2 integer parameters might be more useful. So assert equals int a and int b. And this is what we were kind of looking at on our previous slide with the largest method. We were asserting that when we execute that largest method, that 9 is going to be returned to us, which is an integer. So we're asserting that the two of those are equal. And if they are equal, it'll be true. So there's the example here, assert equals 2 and a. In our one, we had assert equals 9 and largest. We call the largest method. So we're expecting that when that method was executed, it would return 9 to us. So we look at that test largest stuff and plan out a couple of tests. We've broken code that looks reasonable. When you glance over it really fast, it looks reasonable enough, but there's a lot of bugs in it. So what we're going to do is we have a method to test, and what we often call this is our system under test, our SUT. You'll see a lot of the documentation will use SUT. So what we have is we're creating a static method called largest that will find the largest in a list of numbers. So here we have this is our largest static method here, and we are going to pass in an array. So what we're going to test is these guys. So this is 7, 8, 9. This is our supplied test data. We'd be expecting 9 to come out. 8, 9, 7, we'd expect 9 to come out. 9, 7, 8, we'd expect 9 to come out. So see the way we're positioning, we're kind of doing a little bit of boundary testing here, in that we're positioning 9 at the extremities of that array, and then we're positioning it somewhere in the middle. So there are three tests that we're going to start looking at. So this is the code that we have here. And this is one of the sets of tests here. So here we're setting up the index and max variable. And what we're saying is we're cycling over the array here. And we're saying if the list index is greater than the max, max is equal to the list, the one that we're currently looking at. And then we'll return the one that appears to be the largest one. So what we have then is other test data where we've got duplicates. And we've test data where there's only one item. And we've test data where they're all negatives. So these are all the different permutations of data combinations that could go into this method that we want to test. So what we're going to do is write our test case. So the test case, we'll just call it test largest. Okay, and what we have here is we're interested in where the blue arrow is pointing, we're interested in the test, this method. We're going to call it test order. So we're going to make sure that it uses this data here. So 8, 9, 7, and we're expecting 9 to be coming back. So what we're saying is pass out that data. We're expecting 9 to come back when we execute. See the way we're executing down here? We're executing our system under test down here. Largest array. So, and we're expecting 9 to come back from our code. And what we say is this unit test has one test in it. It's got one test in it. It's called test order, and it's got one assertion in it. Whenever you write a test, you're going to have an assertion in it. If there's no assertion, the JUnit framework cannot produce a report basically for you. So when I run that test case in Eclipse, this is what's produced to me. This is my JUnit tab. I run my test. Just, you know, the way you do your run as application, this is run as JUnit. Your lab will step you through how you're going to do that today. So I can see that I've got one test class called test largest. I'm using JUnit 3 as the runner because that's the type of JUnit, the version I'm using. I've got one method called test order in it, and it failed. So it's telling me X there, it failed. And then when I click that, I come down here, you will only get a stack trace, a failure trace, if your method failed. If all of your methods passed, and how you'd know they passed is if you had a green bar here, and all of them would have a green decorator on the icons there, you would know that they were all after passing. And then your failure trace would be completely empty. But because this one failed, I can see that I've got, it's telling me I expected 9, but I got this mad number. Okay, so it's even telling me the line it went down on, 42. Test largest, line 42. Something went wrong when we were executing a piece of code on it, and this is what happened. So this part up here is the status of the automated test execution. Okay, one test ran and that one test failed. It registered as a fail because I had an assertion in it, and that's when it registers. Otherwise, you're going to get no output coming out here. So this area here lists all the test classes and the test methods within them. So I only have one test class in my system and one method within that test class. Most times you have a good few listed down here. And this area down here lists the test that failed along with the assertion errors. As I said earlier, if there's no fails, if you've got a green bar on the top along here, you will have no fails. This will be empty. Why did it return such a huge number instead of 9? So where could this number have come from? Any ideas? It's the max value of an integer. So it's 2 to the power of 32 because an int has 32 bits in it. So 2 to the power of 32 divided by 2 and take the 0 into consideration. And that's that maximum, that's that mad number that we just saw there. So we now know that, okay, it was a bad idea initializing to max value. So we'll set it to 0 and we'll try again. We'll see will our test behave itself. So what we did here was we got rid of that integer.max value and we set it to 0. And then we ran our test again, and now, hey, we got it running, it's great. Our code worked based on our test. But what happens if the largest number appears in different places in the list? We never tested that. We only just tested it appearing in the middle. First, last, we only did the middle. Boundary testing. You'll often see that bugs will show up at your edges, at the boundaries. So we need to test that. We need to make sure that we're basically making sure that we've tested that it's okay when you've got something at the start and something at the end. And what we can do is that test order, I can put as many asserts as I want into it. It'll, it'll tell me if it goes down on one of them, it'll tell me which one it's gone down on, and it'll give me the error, and I can go back in and see. You can have as many as you want in it. And there are other rules for writing these tests, which we will cover with you very soon. But you can put as many as you want in it. So now I've got a failure trace again. It's given out to me. It's fine with 9, 8, and 7. It's fine with these guys, but it's not with this. Okay, so something's wrong at the boundary, the end boundary here. And see the way my failure trace is it's going to be red, it's going to indicate there's something wrong. And it shows me here where the error is, and I can just click on it, and it'll bring me to the line, the assert that went down. So I can double click on this error here, and it'll show me where it's failed. So what happened here was that I had a boundary issue there. Can you see there? List length -1. I had indexes less than list length -1. I should have had just indexes less than list length, or indexes less than or equal to list length -1. So I wasn't comparing the very last item that was in my array. So, and when the largest item was at the end, it didn't return it. So other boundary conditions. What if we have duplicates? So there's a test for duplicates, and there's a test for just one item in the array. So in this case, we've got multi-items that are the same. We've got 2 items, 2 9s, and we're expecting just 9 to be returned, that it doesn't fall over when it encourages or encounters a second 9. second largest number. And then when we only have one item in the array, it behaves itself as well. So now we can see that we've got, see the way we wrote it as test dupes and test one. So there, now we have three test cases, three test methods within our test case. And we can see from the output here in JUnit that all went well. It ran the three errors, it ran the three tests. There were no compile errors and there were no failures in it. And that all of our tests ran successfully. What about negative? That was one of our test conditions as well at the beginning. We had a negative list of details. So what if negative values are coming in? So we'll write another test, this time called test negative. And we will create a list, an array of a series of negative numbers. The largest negative number, 7. Yeah. Okay. So let's see. It fails. And we click on it again and it's saying I expected -7, but the value was 0. So I double click on that and it'll bring me to the line of code that I went down on as well. So this here, choosing 0 to initialize for max was a bad idea, wasn't it? Yeah. So it should have been the minimum value so as to be less than all negative numbers as well. So we should have done that instead. Okay. And that will behave itself as well. If the array was empty, this is considered an error and an exception should be thrown. So what we have here is in our list largest here, we are saying if the list, we've added in this extra piece of code here, if the list length is 0, throw new runtime exception, empty list. So I'm expecting this method to throw an exception to whoever called it and it'll be handled. So public void test empty. So now we've got another test in our test class as well. And what we're doing is we're trying a piece of code. We're trying to run this here with an empty list. Can you see the empty list there? We've instantiated an empty list and we're running our code and we are expecting that it fail. It should have thrown an exception. And if it's catching so what happens here in the try catch is that in this situation here, if I throw an exception on that largest line, largest.largest, if I throw an exception there, anything after me in that try block isn't executed. I abandon the try block and I go straight down to my catch. So I go straight down to my catch. I said I was going to throw a runtime exception, and you can see it's been thrown up here. I've said I was going to throw a runtime exception, catch that, and then I'm saying assert true, because yes, I did throw the runtime exception. I did pass in an empty list. I'm expecting that an exception will be thrown, so this test passes. However, if an exception is not thrown in this piece of code here and I pass in the empty list, so if I'm on my try bit here and it doesn't throw it, I come down here, I execute the next line of code if the exception hasn't been thrown, if something went wrong with that. And that's why I'm printing out a fail message. I'm making sure the test fails and I'm saying, you should have thrown an exception. Something is wrong with the throwing an exception piece of code. So that's another test in it. So some more test-driven development theory, just only a tiny bit now. Test-driven developed you out at this stage, I think. So common pitfalls. So for an individual programmer, you might forget to run your tests frequently. You may write too many tests at once and kind of not write the implementing code and stuff. So, try and write them a little bit hand in hand. You're writing tests that are too large. So in our situation here, we ended up with 5 different tests. And they were very clear. One was test duplicates, one was test the order, one was test negative. So I wrote 5 different individual test methods that did one thing. It was testing one scenario. So sometimes you can write tests that are too large. Of course, I could have put all of my asserts into one single method and ran it, but that would be too large. That would be a situation where I would have far too many asserts going on in one test. Also, writing overly trivial tests. So we look at what we mean by overly trivial. Do you remember that slide I showed you, the very last slide on the last lecture notes, where can I overtest? Yeah, you can, definitely. There's a happy medium as to where you're happy with. Also, you may omit assertions. So yeah, it's a test method, but it's not actually forcing any tests on it. And writing tests for trivial code, say accessors. you can generate accessors in Eclipse for a particular model class. You know, the way we've been writing our model classes, our users, I can just put in my instance variables there, and I can generate all of that code. I don't really need to write test methods for that generated code. So you can over test a little bit, but maybe if I start updating that generated code, then it's a good idea to start testing them. So for a team, common pitfalls, only partial adoption, only some people doing it. So there's no point in doing it if it's only kind of half done. So also poor maintenance of the test suite. Part of the whole test-driven development mantra is that you are going to save yourself so much time in regression testing. So like if you don't maintain your test suite, you're going to have a test suite that isn't fully representative of the system that you actually have built. There'll be a lag behind it, be code rot in your test system. So also you can end up with a prohibitively long running time as well if you're not maintaining the test suite as well with a view to making sure your code is efficient. You can end up with code that will take an awful long time a test suite that will take a long time to run. And also an abandoned test suite, seldom, never run. So team turnover, maybe people come into the team that aren't familiar with how to write it and so on. So they're common pitfalls in teams for test-driven development. Signs of use. How can you tell if your team is using it? If you're in a management position, you want to keep an eye on what's going on with the test-driven development. There are what we call code coverage tools, and I have a couple of slides on that, just literally 2. I'm nearly done with you. So code coverage is a common approach to seeing that you're using your test-driven development. It doesn't guarantee appropriate use of it. It doesn't make sure that the tests are written correctly. What you're doing is making sure that you're catching all the different branches of code, and I'll show you what I mean by that in a minute. Version control. If you're constantly checking, if your team uses a version control system, you can actually look at all of the code that's checked in. And if somebody is checking in test classes the whole time and they're not checking in, if they're checking in their own code, just normal system and the app code, but no check-ins are there for test code, you can see straight off that it's not being maintained, and you can see who's the offenders and what the story is. So version control logs will help you if you're trying to keep an eye on that the team is maintaining your test-driven development suite. So you should pretty much have the same number of check-ins for your code as you should have for your product code as you should have for your test suite. So code coverage, 100% example. So what we have here is this is a thing called a tool called Jacoco, and I look at bringing that in one of your labs. I look at bringing that in into Eclipse for you. So what we have here is this is your tests have run. They're all successful. That's one part of, that's just the JUnit framework here. But what I've done is I've also, this has also run a code coverage report on the testing. So it's great that all the tests have run successfully, but this is another level of checking. And what it does is it's checking all of the paths that can be possibly taken in your code. So you can see different paths. If the null is current, it goes into this piece of code. If it's otherwise, it goes in here and so on. You have multiple different paths in a piece of code. And what the code coverage will do is it will run over, it's a tool that will run over your JUnits, and it will highlight areas that you haven't hit. So this is 100% code coverage here. And you can see the report down at the end here. It's telling you the mini hash map test is 100% code coverage. This is an 85.4% example. So you can see here that this here, the red, that has not been tested. That path hasn't been tested. If C is empty, it hasn't been tested. This hasn't been tested either. So the code coverage has managed some of the little bits. It's done some of the stuff, but it hasn't done all. And in here we have the ternary operator here, which is the reduction of the if statement into one line. And what we have here is that maybe one of those paths is tested. It's half done. So you can see very easily using code coverage what level of testing has taken part in the app. And we would, for example, use this when correcting test-driven development assignments. We'd run a code coverage report over it. Or what we would do, as we've done with you, I think, is we've asked for in one of the rubric, I'm nearly sure that we've put code coverage in there, and that you can generate a site, and we'll show you all that sort of stuff as well. So it's an incredibly handy tool, the code coverage, and that's Jacoco, Jacoco, and you can bring it into Eclipse, and we'll look at doing that. It comes in as, I think it's ECLEMMA or something. It comes in as a weird thing. Yep. But there's our code coverage library. Yeah, that's what it comes in as. So ECLEMMA. Okay, but this is the Jacoco library, and you can have a look at that up there, and it'll tell you how to pull it in. But we'll be looking at that probably with you. And that's it. That's it for week 4 so far. So if anyone has any questions, type away in the chat room there, and we'll talk to you then online tomorrow. So I will see you then. I might be, oh no, I have a meeting tomorrow, I think. So I may be 5 minutes late coming into the chat room, but I will be there. It's just the meeting ends at 3, so I just need to settle myself and just sign on, but I will be there. Okay, so thank you very much. Take care. Bye-bye.